Okay, welcome back. So we've been given a quadratic equation and we are supposed to solve for the value of x using completing the square method. So let's put down our three-step process that we've derived from the previous video. Step 1. We need to rewrite the equation such that it is in the form ax squared plus bx is equal to c. So what this means is that we need to have constants on the right hand side of the equation. Okay, only constants on the right hand side of the equation. Or we need to have the variables on the left hand side of the equation. Okay, in this case our variable is x. Okay, so we need to have the x terms on the left hand side of the equation, or we should have constants only on the right hand side of the equation. So that is step 1. Step 2. The leading coefficient of x squared must always be 1, meaning the number in front of x squared must always be 1. So how do we achieve that? So it means we need to divide the equation by a. So we have ax squared over a plus bx over a is equal to c over a. Okay, so that this a and this a will cancel out, and then the number in front of x squared will be 1. Okay, so step 2, we need to divide through by a so that the leading coefficient of x squared, or the number in front of x squared, is 1. Step 3, we have to use our formula that we've derived in the previous video, which is also fairly easy to memorize. We have two perfect squares. Okay, one is on the left and then the other is on the right. So we have two perfect squares. The one on the left has two terms, x plus k. The one on the right has one term, k. And then we add a constant to it, plus c. And then k is equal to 1/2 b. Okay, this formula has already been proven in the previous video. So these are the steps that you need to know. Once you know these steps, you should be able to solve any problem that relates to completing the square method. Okay, now let's proceed solving this problem. So step number 1. The equation has to be rewritten such that it is in the form ax squared plus bx is equal to c. In other words, constants only have to be on the right hand side, or the x variable terms have to be on the left hand side. So looking at this equation, I have the x variables on the left hand side. I have this constant on the right hand side, but this constant, positive 5, is on the left, so it has to be moved to the right. Okay, it is positive on the left, so when it moves to the other side of the equation, the sign will change, so it becomes negative. So this is the same as negative 3x squared minus 2x. I have my x variables on the left, the 3 is already on the right. I'm moving the positive 5, okay, which is on the left to the right, so it becomes negative 5. Okay, similarly, you can add minus 5 to both sides of the equation, but I prefer moving it to the other side of the equation. Okay, now let's simplify this. This is the same as negative 3x squared minus 2x is equal to 3 minus 5 is minus 2. Okay, so looking at this equation, step 1 has been satisfied. We only have constants, or the constants, on the right hand side, and then we have the variable x on the left hand side. Okay, variable x on the left hand side, constant on the right hand side. Step 1 has been satisfied. So let's move to step 2. Step 2 says the number in front of x squared must always be 1. The leading coefficient of x squared must always be 1. Okay, so in order to achieve that, it means we need to divide the equation by -3. Okay, we need to divide through by -3. So that implies we're going to have minus 3x squared divided by -3 minus 2x divided by -3 is equal to minus 2 over -3. Are you with me? Okay, let's simplify this further. So this is the same as this -3 and this -3 will cancel out. So we are going to get x squared. Negative divided by negative is going to give us positive 2 over 3x. And then similarly, negative divided by negative is going to give us positive 2 over 3. Okay? So looking at the equation now, the number in front of x squared is what? Is 1. So step 2 has been satisfied. Okay? So we can move on to what? Step 3. And before we do that, okay, what is in front of x squared? The leading coefficient of x squared is now 1. So a is 1. Okay? B is 2 over 3. And then C is also what? 2 over 3. Okay? Now let's use the formula. The formula says, the third step, we have two perfect squares. Okay? One is on the left, the other is on the right. The one on the left has two terms, x plus k. The one on the right has one term, k. We add a constant to it. And then k is what? 1/2 b. Okay? So this is the same as 1/2. We now know the value of b to be 2 over 3. Okay? This 2 and this 2 will cancel out because we are multiplying 1/2 by 2 over 3. So this 2 and this 2 will cancel out. And then we'll be left with 1 over 3. So the value of k is now 1 over 3. Okay? So we can substitute. So this implies we have x plus k. K is now 1 over 3. All squared is equal to k, which is 1 over 3, all squared, plus c. What is c? C is 2 over 3. Okay? Let's simplify further. So this is the same as x plus 1 over 3 all squared, okay, is equal to 1 over 3 all squared. This is the same as 1 squared divided by 3 squared. And 1 squared is 1, 3 squared is 9. So 1 over 3 all squared is 1 over 9. And then I have now plus 2 over 3. Okay? Let's move on. Now, I want to rewrite this 3 such that it has a denominator of 9. Okay? The reason why I'm doing that is, so that I can easily simplify it. Okay? Now, if the denominators are the same, then I know that I can add what? The numerators. So I have 1 over 9 plus 2 over 3. I want to make this denominator 9. It means I have to multiply it by what? 3. And what you do to the denominator, you do likewise to the numerator. Okay? So in essence, I have 3 divided by 3, which is 1. Okay? So I haven't done anything. I've only, modified it such that it has a denominator of 9. Okay? So I multiply 3 by the denominator, and I did likewise for the numerator. Okay? Alright. So this is the same as 1 over 9 plus 2 times 3 is 6. 3 times 3 is 9. I now have a common denominator. So I can add the numerators. So 1 plus 6 is 7. Okay? Okay, let me bring down what I have on the left hand side. Okay? So now I'm solving for x. So what do I do? I take the square root of both sides. Okay, so take the square root of both sides. So I'm going to take the square root of both sides. X plus 1 over 3 squared, and then the square root 7 over 9. Be mindful, whenever you take the square root of the constant, it's going to be accompanied by the plus and minus sign. Don't forget that. Okay? Alright. These two, this power and the square root will also cancel out. So I'm going to be left with x plus 1 over 3. And then I have my plus or minus. This is the same as root 7 divided by the square root of what? 9. Okay, when I simplify this further, I have my plus and minus. This is the same as square root of 7 divided by square root of 9. And the square root of 9 is 3. Okay, so let me repeat the term on the left hand side. So now solving for x, I have positive 1 over 3 on the left hand side. So when it moves to the other side of the equation, the sign is going to change. So it will be minus 1 over 3. And then I have my plus or minus root 7 over 3. Okay? So now the denominators are the same. So I have a common denominator. So the numerator, I just put everything together. So minus 1 plus or minus root 7 is equal to x. So the values of x are, I can take the positive side, which is minus 1 plus root 7 all over 3, or the negative side, okay, right here. So I have minus 1 minus root 7 over 3. So these are the two values of x that satisfy the equation. Okay, so x is equal to these two. Alright, so that's how you solve the problem. So with a three-step process, you should be able to solve any problem using completing the square method. Okay, see you in the next video.